Hi, it's Akhil. This is my compiler sixth experiment. This was assembler for SIC, and the aim is to simulate a concept of assembler for simple instruction compiler, which stands for which was the acronym of SIC. Here, we'll give the input, and the input will be split, and it based on the condition which is operand or by checking, it will shows the object code and everything. And first thing is you have to if uh, if the input will be having start for the opcode, like the instruction will be like start, then it will proceed like that. If there's start, you have to start where it after the start. Okay. Otherwise, if there is no value, like we have to initialize the LC if you find start in the program, or else LC should be set to 0, and the input should be fed into a system. And next thing is to check the symbol table. If it's not available, then memory address will be stored there. And there are three types of opcode, like opcode which is present in the op tab. If the opcode which is word, it should be incremented by the LC, which should be incremented by 3, because if it's byte, it should be incremented by 1, which is the size of the thing. And if it's a reserved word, RASW, then it should be incremented by an integer equivalent of the operand value star. Then we go into a program, and here the initialization, like importing the libraries like buffer reader, writer for reading and writing, and this for exception, and IO reader input, like reading from user. This is buffer reader. And then these three are for like similar to this, but with the user. And then enumeration hash table. This hash table library we're using for putting the operands into some hash value. Then scanner for default input and output. Here's the main class starting over there, and throws exception hash table operand, which is readable op table. This is the function we are calling here. This value will be assigned to here, and then a size is 30 for this, and this value will assign to hash tables SOM, and this for buffer read and write. New file reader, this is the location which is gonna be buffered into the buffered BR, and this is the location which will be fed into WR, which is right the string line. Then it should be like string line title is none initially, and we are initializing LC equal to 0 initially and start equals 0. Then with the for loop, we are going like it's like a loop, and if its content starts, we're gonna split it, and with the first position we'll check it if it's 3. If it's 3, the integer in the value which is in second and 16 of the parsin will be stored into start. Then from there it will be, then the LC will be changed. The start will be the value which is here will be stored in LC, or else if this condition is not working, again we start from 0. The start 0 will be in LC, and we gonna write it we gonna write the thing, or else if contains or if you didn't find start, or else if you find a line contains the word end, this value pass symbol update, the update will be stored into LC. Or else if the line contains end, this write hexagon string, LC will be this will be printed, not printed actually. Then the length will be the start minus LC the value which is previously we got, and it will be swapped with the start value. Now the LC value start. Then we gonna close the thing, close the read and write buffer, and we are again reading this from the location, and this is like a similar type. We gonna, if we are checking start, is there any value which is named start, or else if it's fine end, we gonna print E to the 6 hexagon string end. Then this value will be stored in the LC. Then we gonna close the BR1, which is this. Whenever we open the thing, if we finished it, we have to close it, or else there will be some error, it won't work properly. And the next thing is we are getting the word, and which by a for loop we are checking the word, like we are adding the word, we are getting the word from using a for loop. And if it's contained the sentence 2, this thing is about finding the opcode, this is for checking if it contain reserved word, reserve byte word. Like for this for allocating this for if it contain reserve word, this will be the thing. If it contain reserve byte, lc plus equal to this value will be stored in lc plus, or else if it's contain just a word, the value 3 will be like stored in lc. And the next thing is we are updating the hash table operator symbol table buffer reader writer. This line split based on white space will be stored in the string. And if it contain a key of 0, if it contain matches with a to z or anything and contains a keyword 0, it will put in the first array, or else a label already exists. Like if you find the same thing again and again, it prints this already. And if both any condition does not satisfy, it will show the label is invalid. And here is also similar to that. If you finding reserve word, this value will be stored here. It's the hash table optable hash table ready optable class, which throws an exception. We are the value of hash table, the capacity will be stored in operator. We want to read this file from this location, and we declaring string line using a for loop. We are getting the input, and finally we are closing it. The result will be like, if you this is the program text, the optable, like if you type this this is if this is input, the optable test will be like this, and the inner test to this will be for converting to hexagonal for addresses using the thing. And finally the output will be like this. Copy this, these are the hexagon values, and that's all. Thank you for listening.